Hello students, today's video is on statistics, which is very important and super easy topic. It is important as you get one question from this topic in JEE, and within couple of minutes, rather we should say within couple of seconds, you will be able to solve that question. I'm trying to cover the variety of concepts and questions in one shot, so watch this video till end. Now we have two types of data, and those are categorized in, first is written here ungrouped data and another is group data. So for ungrouped data, what we get xi's, and those are x1, x2, xn. These are observations. And for group data, we have two types of data. One is discrete frequency distribution and another is continuous frequency distribution. In discrete frequency distribution, we have xi's and fi's. But in continuous, we have suppose this 0 to 10 class interval, 10 to 20, 20 to 30, and then we find the mid value, those are xi's, and we have frequencies of those, so these are fi. So we just obtain xi, that is the mid value 5, 15, 25, and so on. And fi's are the frequencies. But in JEE, usually we get question from ungrouped data, and mean is denoted by x bar, and for ungrouped data, mean is sigma xi upon n, where sigma xi means sum of the observations upon number of observations. And we get question, we may get question from discrete frequency distribution, and for that mean is x bar, and the formula for mean is here fi xi upon sigma fi, which is also known as capital N. So fi xi, sigma fi xi means you have to multiply f1 into x1, f2 into x2, f3 into x3, and then find their sum, that is the numerator of this formula, and sum of fi's, sigma fi is the sum of the frequencies, that is denoted by capital N here. So this is the formula for discrete frequency, mean of discrete frequency distribution. Now this is very important, variance. So variance is denoted by sigma square, and one formula is, that is xi minus x bar whole square upon number of observation, that is n. That means if we have observations x1, x2, x3, we just find out mean and we subtract mean from each of the term. That means x1 minus mean, then square it, x2 minus mean, then square it, x3 minus mean, then whole square, and sigma, that means sum of all these terms upon number of observation. So we use this formula when we get independent values of, that means if we get x1, x2, xn, suppose 2, 4, 6, 8, these are my x1, x2, x3, and x4, and then I find out mean value of this, that is 2 plus 4 plus 6 plus 8, and this is 20 upon 4, as I get mean here 5. So what I do, in order to find variance, I just subtract 5 from 2, that is x1 minus x bar is here 5, so 2 minus 5, I get minus 3, square of it is 9, 4 minus 5, that is, and this is how 9, 4 minus 5, I get minus 1, but the square is plus 1, And 6 minus 5, I get again 1 and square is 1. 8 minus 5, I get 3 and its square is 9 upon number of observations, those are 4. So this is how I get variance. But another formula of variance is, which I derive by solving this. If I open the sigma, I deduce this, and the formula is sigma xi square upon n minus sigma xi upon n whole square. And you know that this is what this is mean. Or further, you can replace it by this, and the variance is equal to sigma xi square upon n minus x bar whole square. So we have two formulae. One is this. This we use when I get independent observations like 2, 4, 6, 8. And another formula is either this or this. This formula we use when we get the sum of the observation, that is sigma xi. So we put the value of sum of observation here. And also if we have sigma xi square, that is sum of the square of the terms, if we get these two quantities, then we use this formula. Or if we have mean and sum of the square of the term, then we use this formula. So according to given condition, we use the formula of variance. Now what is standard deviation? Standard deviation is what the square root of variance and is sigma. That means if I get my variance as 16, then its square root standard deviation is 4. So standard deviation is what? The square root of variance. Now, next, what is written here? The mean and the variance of first n natural numbers. We have to find the correct option. And as you all know, that sum of first n natural number, that is sigma k, k is from 1 to n, is what? 1 plus 2 plus 3 plus n. This is what sum of first n natural numbers and is equal to n into n plus 1 upon 2. Similarly, sum of square of first n natural numbers is k square. K is from 1 to n, and it is 1 square plus 2 square plus n square, and is equal to n into n plus 1 into 2n plus 1 upon 6. And sum of cube of first and natural numbers, sum of cube of first and natural numbers is sigma k cube. K is from 1 to n, 1 cube plus 2 cube plus n cube, and is equal to n into n plus 1 upon 2 whole square. So in this question, what I have to find the mean and the variance of the first n natural numbers. And first we deduce the formula. That is, first we find the mean and the variance of first n natural, and then we use this as a formula. Now look, in order to find mean, that is x bar, we know that this is sigma xi upon n, and sigma xi is here sum of first n natural number, which is n into n plus 1 upon 2. So I replace it by n into n plus 1 upon 2 divided by n. So what I get? N plus 1 by 2 is my answer. So my answer may be second option or third option, because in second option I have n plus 1 by 2 as mean, and in third option as n plus 1 upon 2 by n plus 1 upon 2 as mean. So either 2 or 3 is my answer. I have to find variance, and for variance, formula is sigma square. This is sigma xi square upon n into x bar whole square. Sigma xi square is replaced by sum of square of first and natural number, that is n into n plus 1 into 2 n plus 1 upon 6, and further this n, and x bar as I have already deduced it, that is n plus 1 by 2 whole square. That means I just substitute the value of mean of first and natural number, that is n plus 1 by 2. Further, if I have to find mean of first 50 natural number, then I just replace this n by 50 here. So this is my formula for mean of first n natural number. Now I have to find variance. Now if I take n plus 1 upon 2 common here, within bracket I have 2n plus 1 by 3, n plus 1 upon 2. After taking LCM, 4n plus 2 minus 3n minus 3 upon 6. This is n plus 1 upon 2. This is n minus 1 upon 6. So my answer is n square minus 1 upon 12. So the correct option is option 2, because mean is here n plus 1 by 2 and the variance is here n square minus 1 upon 2. Now I have obtained my formula. This is what the variance of first n natural numbers. Suppose if I have to find the variance of first 50 natural numbers, then in that case I just replace this n by 50. Now for the application of this is, now look, few more results. What I have written, if we add, subtract, multiply and divide each and every observation by a constant a, then new mean will be x bar plus a. If I subtract, then I get x bar minus a. If I multiply each and every term by a, then I get x bar into a. And if I divide each and every term by a, then I get x bar by a. But in case of variance, there will be no change in case of addition and subtraction. But in case of multiplication and division, new variance will be sigma square a square and sigma square by a square respectively. Same for standard deviation. What does this mean? Suppose my observations were x1, x2, xn. And if I add a throughout, then I get x1 plus a, x2 plus a, and xn plus a. Now my new mean, if I add a throughout, my new mean will be x bar plus a. Similarly, if I subtract a from each and every term, then my new mean will be x bar minus a. Suppose I multiply each and every term with a, now my new mean will be a into x bar. And for division, if I divide each and every term by a, then my new mean in this case will be x bar by a. But for variance, this is my first case. For variance, if I add a throughout, in this case there will be no change in variance. Variance will remain sigma square. Second case, if I subtract again, there will be no change in variance. This is my third case. If I multiply, that means in both the cases my variance will be sigma square. But if I multiply a throughout, then my new variance will be a square sigma square for third case. For fourth case, my new variance will be sigma square by a square. Suppose if I multiply 2 with each and every term, then my new variance will be 4 times sigma square a square. If I divide each and every term by 2, then in that case, my new variance will be sigma square by 4. And same for standard deviation. There will be no change in first case, no change. When I add, no change, that is the second case. But that means in case of, if I subtract, there will be no change. But if I multiply, then my new standard deviation will be a into sigma, because variance is the square root of, sorry, standard deviation is the square root of variance. So my new SD will be this. Same is for fourth case, that if I divide each and every term by 8, then my new SD in case of division will be sigma by 8. So here is the application of this result. If the SD of -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5 is root of 10, the SD of the observations 15, 16, 17, 18 till 25 will be. As you can see here from this last term, if I add 20 to this, I get 25. If I add 20 to 4, I get 24. If I add 20 to this, then I get 23. Similarly, if I add 20 to -5, I get 15. That means in each term, I am adding 20. So if I add same constant throughout, there will be no change. So my SD will be here, third option, that will remain root of 10. Another application here, very important. The variance of first even natural number, in this case, I have to find. I have obtained variance of first n natural numbers, and my formula was n square minus 1 upon 12. First n natural numbers were 1, 2, 3 till n. But first n even natural numbers are 2, 4, 6 and 2n. Here I have to find first 50 even natural numbers. So in place of n, I just replace this by 50. Here again, I replace it by 50. So now this first number can be written as 2 into 1. This 4 can be written as 2 into 2. This 6 can be written as 2 into 3. And if this is 50, then this is 100. My 50th even number will be 100. And this 100 can be written as 2 into 50. As you can see here, that if first 50 natural numbers were 1, 2, 3, 50, then first 50 even natural numbers are obtained by multiplying 2 to each term. That means if I multiply 2 to this, I get 2. If I multiply 2 to this, I get this. If formula for variance for first 50 natural number, if variance of first 50 natural numbers is, I just replace this n by 50, is 50 square minus 1 upon 12. Then if I multiply 2 to each term, then my new variance, that is the variance of first 50 even natural number, will be, if I multiply 2 to each term, then I have to multiply variance by 4. So what I get, this is 2500 minus 1 upon 12, and what I get, 2599 upon 3. So my desired answer is here 833. As you can see here, each and every term is multiplied by 2. So for variance, I have to multiply variance by 2 square. So my answer is here 833. 33. Another application. This question came in January 2020 paper. If the variance of first n natural number is 10 and the variance of first m even natural number is 16, you have to find m plus n. As you know that variance of first unnatural number is n square minus 1 upon 12 is equal to 10 here. That is n square minus 1 is equal to 120, n square is equal to 121, and n is here plus 11 because this is natural number. Now next, what is given here? The variance of first m even natural number is 16. If variance of first n natural number is n square minus 1 upon 12, then variance of first m even natural number would be 4 times m square minus 1 upon 12 is equal to 16. That means what I get from here, m square minus 1 is equal to 48, m square is equal to 49, and m is here 7. And what I have to find out? M plus n. So that is 11 plus 7, and my answer is here 18. Another application. This question came in again January 2020 JE paper on 9th January morning shift. Let the observations xi satisfy the equation this, that is sum of xi minus 5, I is from 1 to 10, and sum of squares, I is from 1 to 10 is 40. If mu and lambda are the mean and variance of observations x1 minus 3, x2 minus 3, x10 minus 3, then the ordered pair mu comma lambda is equal to. Now look. First of all, we write what is given to us, that is xi minus sum of observation I is from 1 to 10. That means n is here 10. Number of observations are 10. What else is given? Xi minus 5 whole square, I is from 1 to 10. The square is also given to us. Now, I is from 1 to 10. That means our observations are x1 minus 5, x2 minus 5 till x10 minus 5. These are my observations. But what we have to find out, we have to find the mean and variance of observations x1 minus 3, x2 minus 3, x10 minus 3. That means I have to find the mean and variance of these terms. As you can see here, I can obtain x1 minus 3 from x1 minus 5 by adding 2 to each term. So if I add 2 to each term, then my new mean would be x bar plus 2, right? So first we find out my old mean. My old mean is here sigma xi minus 5 upon number of observation, that is 10, and sigma xi minus 5 where I is from 1 to 10 is given to us 10. So I replace this by 10 and I obtain my new mean as, so my old mean was x bar equal to 1. And according to result, that is, I obtained these observations x1 minus 3, x2 minus 3, x10 minus 3 by adding 2 to my old observation. So my new mean would be, that is, you can say x1 bar is old mean plus 2 and my new mean would be 3, which is given here mu. So my mu is here 3. Okay. What else I have to find out? I have to find out lambda, which is the variance. And as you know that if I add 2 to each and every observation, there will be no change in variance. So what is my old variance? And my new variance will remain same. So formula for my old variance is this, and this is what? Right? So there will be no change here. And what I get here? So this is again 3. So my lambda is also 3 because there will be no change in variance, and whatever will be the old variance, that will remain my new variance. And my old variance is, I have used the formula of variance here, and that comes out to be 3. So in the form of ordered pair, my correct option is 3 comma 3, which is my option 1. Hello. In this question, if for some x belongs to set of real numbers, the frequency distribution of the marks obtained by 20 students in a test. These are marks, that means these are xi, and this is what fi. And you know that if 20 is given to us, that means sigma fi is here 20 or is capital N. So this question is of frequency distribution. So first of all, we just find the value of x. And how we find that? Sigma fi is here x1 plus 1 whole square, sorry, x plus 1 whole square. That is the first frequency, f1, which is written here, plus f2, plus f3, and plus f4. So this is f2, this is my f3, and this is my f4, and is equal to 20. On solving this, this is 2x squared plus 2x, this is 4x minus 3x, and x plus x 2x, and this is 6, so minus 4, and I get here minus of 24. So this is my quadratic equation, and if I solve this, so what I get from here, I get two values of x, and those two values are x equal to 3 and x equal to minus 4, and I neglect this value because this is the frequency, that is what the number of students, which can never be negative. So my x is here 3. So I have obtained the value of that, x is here 3. Now what I have to find out, I have to find the mean of the marks, and for frequency distribution, the formula for mean is x bar, that is sigma fi xi upon sigma fi, where sigma fi is 20 given to us, and fi xi is what the product of x1 into f1, x2 into f2, x3 into f3, and x4 into f4. So what I get here, so this is 2 into x plus 1 whole square, 3 into 2x minus 5, 5 into x square minus 3x, plus 7 into x upon 20. Further, I just replace x by 3. So what I get from here, this is 2 into 3, this is what 3 plus 1, that is 4 square. This is 2 into 16. If I put x equal to 3 here, this is 6 minus 1, that is 1. 6 minus 5, that is 1. So this is 3 here. If I put x equal to 3 here, this is 3 square minus 3 into 3, 9 minus 9. So I get 0 here. And 7 into 3, I get 21 here. So what I get from here, this is 32 plus 21 and plus 3 here. So I have missed one term. That is, this is 6 minus 1, 1, 3, then 0, and then 21. So my answer is 56 by 20, and which is 2.8. So my correct option is here, B option. Now, what I have written here is a formula, and this is what the relation between mode, median, and mean. You know that mode is 3 median minus 2 mean. So this question came in 2005. If in a frequency distribution the mean and median are 21 and 22 respectively, then its mode is approximately. I have to just substitute the values. Pre-median, median is here 22, and 2 mean, and mean is here 21. So my answer is 24. So this is what the application of the formula. Mode is equal to 3 median minus 2 mean. Now next. One more result, that is from the formula of mean. Mean is x bar is equal to sigma xi upon n. If mean is given to us, we can find out sum of the observation. As if mean is given to us 8, and suppose number of observation is given to us 10, then from the formula of mean, I can find the sum of the observation. Just I have to put the value of x bar here 8, sigma xi, which I have to find out, and I replace this n by 10. So from here, I can find out x sigma xi is equal to 80. That means from the formula of mean, if mean is given to us and number of observations are given to us, we can obtain sum of the observations. Similarly, if standard deviation or variance is given to us, then from the formula of variance, we can find out the sum of the square of the observation. As if sigma is 4 given to us, that is standard deviation is given 4 here, then variance will be 16, and formula of variance is sigma square is equal to sigma xi square by n minus x bar whole square. So I just replace this sigma square by 4 square, that is 16, sigma xi square, which I have to find out. N is here 10, and x bar is what, the square of mean, which is here 8. So what I get here, 8 square, that is 64. And if I take the 64 to left hand side, so this comes out to be 80. And as you can see, we can obtain sum of the square of the terms from the formula of variance. From mean, I can find out sum of the terms, and from variance, I can find out sum of the square of their terms. I'll look at this. The mean, this question came in 2015. The mean of the data comprising 16 observations, that means n is equal to 16 here, given to us. If one of the, the mean of the data set comprising 16 observation is 16, that means mean is also 16 here. If one of the observation valued 16 is deleted and 3 new observations valued 3, 4 and 5 are added to the data, then the mean of the resultant data is. That means n is 16 here, x bar is 16 here, and I have to delete 16, that is the incorrect observation, or replace 16 by 3 observations, 3, 4 and 5. So as you know that x bar is sigma xi upon n. Here my x bar is, my mean is here 16. Number of observations here again 16. So from the formula of mean, I just obtain the sum of the observations, that's 16 to 16, 256. Now I have to find new mean. We have to find new mean when we replace 16 by, when we replace one observation which is 16 by 3, 4 and 5. Then in that case, my new mean would be 256. Sum of the observation, we have to subtract 16 from here, and in place of this, I have to add 3 plus 4 plus 5. If we had 16 observations, number of observations were 16, and if we replace this by 3 observations, then from 16, I just take out one observation, we are left with 15, and then we add 3 more observations, that will 15 plus 3. Now my total observations will be 18. And my new mean is here 256. This is what, minus 16 plus 12, that is minus 4. And this is 252 upon 18. So my answer is here 14. So next. Now this question is on combined mean and combined variance. That means we have two data. For two data sets, each of set size 5. That means number of observations. Suppose I denote first data by xi and second by yi. Number of observation in first, that is n1 is here 5 and n2 is again 5. Both have same number of observation as this is given in the question. The variance are given by 4 and 5. That means variance of x terms are 4 are sigma square, and for this is given to us 5. What else? The corresponding means are given to be given to be 2 and 4 respectively. That means x bar is here 2 and y bar is here 4. And what I have to find out? I have to find out the variance of the combined data. Now, if we have two data, then in that case, one is denoted by xi, that means terms are x1, x2, x3, and second is denoted by yi, that is y1, y2, y3 and yn. Then the formula for combined mean is that is the new mean, which is the combined mean of two. Formula for combined mean is n1 x bar plus n2 y bar upon n1 plus n2. And the variance, that is the combined variance, the formula for combined variance is sigma xi square plus sigma yi square upon n1 plus n2 minus x bar plus y bar upon 2 whole square. That means we have to find, in order to use this formula, I have x bar, that is 2, I have y bar, that is 4, but I don't have sigma xi square and sigma yi square. As I already told you that sum of the square I can obtain from the formula of variance. So I just find the value of sigma xi square and sigma yi square, and then I just substitute values here, and then I can find out the variance of combined data, that means combined variance. Now, formula of variance is sigma xi square upon number of opposition is 5 minus x bar whole square. So here variance is given to us 4 sigma xi square upon 5, and mean was 2, therefore this is 2 square, and from here what I get, this is 4 plus 4 18 sigma xi square upon 5. So value of sigma xi square is here 40. So and from sigma, this for second data, my formula is sigma yi square upon 5 minus y bar whole square. This is given to us 5. So I just replace it by 5. This is sigma yi square upon 5 minus the, I just put the value of y bar here, that is 4, and that this comes out to be 4 square. 16 plus 5, 21 sigma yi square upon 5. Sigma yi square is here 105. Now just I substitute these two values in my above formula, that is the formula of variance, and combined variance, formula for combined variance I'm just rewriting here, is sigma xi square plus sigma yi square upon n1 plus n2 minus x bar plus y bar upon 2 whole square. So I'm just substituting the values. Sigma xi square is here 40, yi square is here 105 upon 5 plus 5, that is 10, and this x bar plus y bar is, I think that is 2 plus 4 upon 2 whole square. So on further solving, what I get comes out to be 145 upon 10 minus 9, that is 145 minus 90 upon 10, that is 55 by 10, and that comes out to be 11 by 2. So my desired option is here A option, that is 11 by 2. So I'm sure this video will help you a lot, and I'll catch you guys very soon with new video. Please like and share the video and subscribe my channel Method Wise. Thank you.